Welcome everyone. I'm Sammy. I'm the CEO of Eventual, the company hosting this event. We build a distributed query engine for multimodal data, so you're in the right place. Cool. A little bit about me. I come from a high-performance computing and AI background. I was a researcher at Berkeley. I did my first foray in startups right after college. I was CTO of a startup called DeepScale, which built autopilot for everyone else. And ironically enough, was acquired by Autopilot. And then after that, stayed in self-driving, was on level 5, where I worked on a variety of things, including distributed training infrastructure, distributed data loading, deep learning compilers, and a bunch of other stuff. I am a GPU guy. I've been programming GPUs for like 18 years. So if you guys want to talk GPUs, how to make them go on supercomputers or embed them on some small embedded potato computer, talk to me. And yeah, if any of this stuff is interesting to you, come find me after or email me. Cool. So the topic of my talk is why multimodal data requires new tools. And so I am sure. Okay. So what makes data multimodal? And so I'm sure you heard this term for the first time just recently. Before that was probably called unstructured. Maybe you heard the word complex at some point. So what makes data multimodal? And I want to kind of come at this from first principles. And so let's take a look at something like an integer. I'm sure you guys all know what an integer is. It's a number. And on a computer, we represent it with a series of bits. And these bits can be 0 or 1. And a number like 42 would be represented this way. And so for a computer, they can store this in a really simple way, just 8 bytes of numbers. And if I want to run an operation like adding 2 numbers or incrementing a number, I can map it to an operation the computer can do. And so this is quite simple. Now, let's go a little bit more complex. Let's think about strings. So I'm sure that you guys have also seen strings when you program or in a database, and it's a little bit more complicated. And so something like hello world doesn't just essentially map to a series of bytes. It actually needs to be encoded in some way. So in this case, it actually maps to 11 bytes. And in this case, it's actually quite simple, but you might have something like a Chinese character or an emoji. And if you have that, you have to use something like an encoding like UTF-8 to map what we understand to something that a computer understands. But what this also means is that if I want to run an operation like lowercase, split by string, find if it has the word world inside of it, what I have to do is write software that understands this encoding of UTF-8, right? So that's kind of some complexity we have to add to our system. Now, what about something like images? So here's an image of like a astronaut on a horse. And we look at it and we see it as like a series of pixels. We see red, green, blue, aligned in a matrix, and it's represented this way. But we can't store it this way. It's intractable to store everything as its raw, uncompressed form. And so to actually store it and send us to different systems, we use an encoding like JPEG. And I'm sure if you use the internet or download a Facebook picture, you see it's a PNG or a JPEG. And so this actually requires the software to understand what a JPEG is, what an encoding is, how to map it from pixels to something like this compressed byte stream. And for this, it has to understand like a DCT and a bunch of other Fourier stuff that I'm not going to go into, but will at some point. And this requires software to understand JPEG images, these advanced operations, and also what pixels are. Now, let's go multimodal. Now, what if I have this image and I want to ask it a question like, what is this image? And I want to answer like an astronaut on a horse. This requires understanding what this image is, what's the encoding, what is the encoding of my prompt, and actually how to run that prompt on this image. And that requires running a model like Lava, it's a multimodal model. It also requires understanding how do I get this model and actually run this model? Like how do I find the right GPUs? How do I place this on GPUs? And how do I do things like pre-processing? Like if I need to tokenize the text and the image, how do I do that? So this kind of requires understanding all of this at the software level when the user asks a simple question like that. So what is multimodal data? And my answer to that is it's encoded data that requires compute to answer a question. And so in the case of an integer, we had a bunch of bits and we could just run an operation on it and we get an answer. The answer is pretty interpretable by us looking at it. But if you have something like an image and a question like, what is this image? It requires a question and computation to get an answer. And depending on the computation and depending on the question, it actually can vary quite a bit. And so oftentimes this question is actually deferred at the time of querying rather than the time of ingest. So what's out there today? And the way I think about this is in 2 dimensions. In 1 dimension, you have the scale of your data. And this is just, how much data do I have? This is, do I have like something I can fit on a laptop, or do I need something like cloud storage, right? And the second dimension is, what is the flexibility of operations? Can I just do stuff like lower string and I want to add 2 numbers, or do I need to do things like run complex models, tokenize my input, maybe resize some images? And if you look at the tabular space, you have things like ETL, analytics, and ML. And they either are low in scale or low in flexibility. And so they're actually not intractable to run. However, when you go multimodal, you have to do things like large-scale batch inference, run GPUs, tokenize. It gets quite complex very quickly. Or you run on very large scale. I'm sure you have seen things like GPT-4 or these new models that essentially train on the entire corpus of text on the internet. And so let's look at some of the tools we have here. I know I'm wearing a Daft shirt, but I'm not biased, I promise. I really am not. So we kind of see 2 clusters that emerge. One is these big data analytics tools, things like Spark and Trino, and these small data tooling, things like DuckDB, Polars, and Pandas. Let's go into these small data engines first. And I'm not trying to knock Pandas here. I know Chung created it here, so I'm not gonna shit on it too much. But these are great for interactive work. If I have data on my computer and I want to ask some questions about it, these are great tools for that. However, these are not great for when I want to go up in scale. And the reason for that is quite interesting, because you would think like, I can actually just get this workload and distribute it over a cluster. Okay, that's actually harder than it sounds, because I have to get my data, figure out how to break it down, figure out how to actually distribute my workload onto these machines, and then finally get that result, bring it back together. And so you're like, hey, Sammy, why don't you just get a bigger machine? And that's a good idea if you're really compute bound, but often these multimodal workloads are dominated by I/O. And if you want AWS and you say, I want the biggest machine possible, and you kind of look at the trend line of, I want to increase the number of cores, the cores can actually go quite large, but the I/O, the connection it has to cloud storage, doesn't increase at the same rate. So you end up with something that's very compute dominated rather than having that much I/O. Now, what about the big data engines? So what are these good at? These are great for analytics. Like if I want to do a big aggregation of revenue for the last 30 days, this is a great tool to use. If I want to do a transformation of my rows of data, let's say I have a bunch of JSONs and I want to parse it and then put it into my data lake, that's also a great tool to use. But these are not great for ML and AI. And here's why. The type system kind of follows convention from like old databases or maybe Java. You have things like integers, strings, floats. They don't have things like images, tensors, embeddings, and these other multimodal types that we now need today. And the second bit is that machine learning is pretty much all written in Python today. If you want to do machine learning, most things out there today you have to essentially grab from GitHub is in Python. And so what we care about is first-class Python support. But in something like Spark, with the way you would do that, even though it has a Python API, is you would actually define a function, we would package it in something called a pickle, send it to a Java worker, which would then send it to some Python worker somewhere else. And let's say, I'm bad at spelling. I have a typo in my key, in my dictionary, in my user-defined function. Now that error has to now be propagated from my Python worker to my Java worker to me, and I'm debugging a distributed system on my laptop. Like, why is that happening? Like, I 100% believe we should have a great local development story, and this is not going to give it to me. So we came up with the multimodal manifesto, and hopefully it doesn't sound like too serial killer-y, but the key points for me of like, what do I want from my multimodal tool? And I think these are kind of the axioms I have there. Number one, we want a great local and distributed Python user experience. Like, we should be able to run our laptop, it works, and I should be able to go on the scale I need. The second bit is we need to have a rich type system that can express the workloads that we need in an easy and seamless way. I shouldn't have to like put my image in an arbitrary binary column and then remember what it is. Like that's not good enough. And last is we are dealing in Python today, and so we should have a first-class Python user experience. Some secondaries that we believe in that you need or SQL support for the other people who are not expressing these workloads and they still need to interact with these systems. And finally, efficient data loaders. This data needs to be ingested by these end systems and need to be able to pull it very, very quickly. All right, let's get Daft. So, type system. So today, Daft supports a rich type system. We support images, tensors, embeddings, sparse tensors, like this entire ecosystem of types that you would need for building these complex applications. And so today, you can actually start with a URL, let's say an S3 URL, the JPEG. You can actually download it into a series of bytes, decode it into an image, and Daft also packages a bunch of common operations you might have. We include things like, how do I resize this image to that image? So it has that encoding, and it has that like lore of how to know how to deal with an image. The next thing is a first-class UDF experience. So much like Ray that you might heard of already, you can actually express a UDF as like a class here. You can actually say, this is my UDF, this is how I build it, this is how I call it, and this is the return type. And then now you should be able to run this on your data without necessarily thinking too much about dependencies or debugging or PDV. Like, it should just work out of the box. And finally, we want a great local and distributed user experience. And the way we do that is actually when the user asks us a question about their data, we actually take as an input as a data frame API or SQL. We then translate that into like some kind of plan, optimize that plan to figure out what is the best way to run this, and then map it to either like a local runner to run your laptop or run it over a distributed cluster. And so this seems like Daft checks all three from the manifesto. So we're pretty happy with that. Cool. And if there's a use case that we didn't cover, come talk to us, come find us, come talk to us. We love building. And yeah, we're also hiring, as Chen mentioned. So come find me or email me or Jay. You have a bunch of our folks in the Daft shirts. Come find us and talk to us. And yeah, that's about it for me.